Hey everybody, my name is Mark. Find out more about me at mark-w.com. Today I'm going to deliver you the bare bones, absolute simplest way to get an instance running on American Cloud. We're using their cloud compute service. I'm going to be running a very small Python application. And this is everything you need to have some of the Python infrastructure working, have this automatically run at reboot, have access to pull code. There's a deploy script, there's a startup script, everything you need to get it going. Bare minimum, this is what you need to build upon. So with that said, let's get started. I have the tutorial that's included with the repository here on my other screen. So I'm going to be following that so that you can follow along with me. So the first thing you want to do is create an American Cloud account, give them your credit card, and then you'll have access to this dashboard here. And the first thing you will want to do is create a project. I'm going to skip that. And then after you create a project, you go to Cloud Compute, create yourself an instance. I skipped creating projects because I already had some in here. And we are creating an instance. Now we go to the provisioning stage. I'm keeping this very, very simple for provisioning. I'm picking US West 0, and you have your choice between VPC and Elastic Cloud. I like the Elastic Cloud. And then we want a standard server type. Now we get to choose our server image. I'm a long time fan of Ubuntu. I've been using it for over 15 years. So I'm choosing the newest LTS, long-term support, 2404 Noble. Now we give it some memory and some CPUs. We're going to keep this bare minimum. So 1 virtual core, 1 gigabyte of memory, and we will do the minimum of 25 gigabytes storage. And we are provisioned. There we go. It's about $16 a month at current pricing. And we will deploy. We're creating our first instance right now. This takes about 1 minute to get completed. So I'll tell you a little bit about the application that we're running in the meantime. The application is maybe 20 lines of code, 1 Python package, and all it does is run on an infinite loop and every 15 seconds send a message to Slack via a webhook. So that's it. This proves that your app is running. It's running indefinitely, and it is connecting with external services. This is not a web-facing app. No port 80 is open. I'm not doing a database. All of that is outside of the scope of this tutorial. I'm more of a WebBot scraper guy nowadays in the work that I do. So this is kind of the base of what I build upon for my apps. This isn't necessarily production ready, but it is the foundation you would use to build a hardened production app, or dev apps, test apps, any of that stuff. So while this is provisioning, let's get ready to shell into the instance. The command is very simple: SSH your user, which is cloud at whatever that IP address is. Looks like we may be provisioned. There we go. We want to accept our new fingerprint. And then we have the password. Nope, wrong password. I did not have it. I had the IP address. So I may be showing you my password here. Trust me, everything will be deleted before you ever see this video. There we go. We're in. We are working out of our home folder, cd change directory tilde, our home, and our user is cloud. And we have nothing in there right now. So let's get moving. The first thing we want to do is modify the release upgrades file with a very simple edit. This edit will allow us to pull packages. And we need to do that because there's stuff that we need to add. So we just flip that to normal, save the file. That is done. Now, this is a great time to get an update for your server because now you can actually do the update. And it should only take a second because we're pretty much up to date. It's a current image. With that complete, we're going to move on to some SSH work. We're going to do generate a key pair, a private public key pair. I'm going to save it as ID under RSA, which is the default, skipping the passphrase, and we have a key pair created. We will need that in 1 second. And I can type. There we go. Now we have our public-private keys, and we want to add this information to GitHub and generate a deploy key. This will allow us to This will allow us to pull code from GitHub and connect securely to GitHub, provide permission to even a private repository in GitHub. So let's add a deploy key. The first thing you want to do is give it a good title so you know what the heck it is. A couple months from now, you may not remember what you were doing. Now we are primed and ready to add the public key. So the easiest way to get is just to cat the public key. It ends in .pub. It should be shorter than the private key. And we want to grab all of this information from the beginning where it says SSH-RSA and it ends with something that looks like an email address. There's other keys that you can use, but I'm just keeping it simple. Allow write access? No, there's no reason for write access. Give me a reason why you want write access, but we just want to read the repository and pull new code in. We have our key in there. We are done with that. Next, we will pull our code. Okay, so we're going to pull our code from the repository now that our key's been placed. This command might be different for you based on where you're pulling it from. I highly recommend you keep the project name as AC_Python just for the sake of the tutorial. Otherwise, you're going to have to do some search and replace for any pathing that's included on this. We want to accept the fingerprint, and we should have code. Look at that. We'll change directory into that. What did we get? The repository. Love it. Exactly what we wanted. So the next part of this is adding the Slack webhook. Then I have instructions on how to get that webhook from Slack included in the tutorial. I've already done that work. So I'm just going to skip ahead and place that in the instance. So the way that we are placing this in the instance is we are editing the environment file. And we do that by editing the etc/environment file. And what we want to do is we want to add a key value pair. Okay, the key is Slack_webhook equals, we wrap it in quotes, and then I have my key right here, or my webhook. We paste that in there, end the quotes, and we are good to go. So what that does is it adds a key value pair to the environment file. When the server reboots, it reads the environment file and it hydrates the session with those key values. So this is where you would maybe store passwords or something like that. There's more than one way to hydrate the environment. This is a very straightforward one, and you can, build upon this basics. We do not have access to that information yet, so we can't run the application. So this is a perfect time for you to reboot the server. So we're going to reboot the server so we can hydrate that. And as soon as it begins to reboot, we get kicked out. We're ready to log back in. I'm going to grab the password. Port 22 is not quite open yet. Just banging at the back door there. All right, and we're in. Oops. My keyboard is at a slight angle, and that is just horrible for my typing. So the easiest way to check if that key value pair is included in the environment is to use the print environment command. And we see down here at the bottom, we have Slack webhook equals something ending in 9ZT and confirming 9ZT. So that looks good. On to some Python infrastructure stuff. The first thing we're going to do is install the Python pip package. We want to say yes to that. And the Python pip package allows us to grab code from Python's package repository, standard operating sort of stuff. I'm using pip here because pip is table stakes for Python dev. Everybody should know pip. I've included a requirements.txt file in here. So let's just keep it simple. I usually go for pip env for my local development, but this works just fine. So we now have the pip installation, and now we're going to add one more package, and this is the virtual environment package. The actual command may differ a little bit for you because it seems to be serialized to the Python version, so that's very easy to figure out. Even Ubuntu will prompt you if you want to goof around with that. Okay, we now have virtual environment installed. What we want to do is change directory into the AC Python folder. All right, and we are going to create a virtual environment in that folder. So that command right there is creating a virtual environment in a folder named .venv. Now, you won't see it if you ls, but if you do ls-al, you will see it. The dot kind of hides it a little bit. I kind of like that convenience. Additionally, using the .venv matches up with the git ignore file that I have. And what that will allow you to do is download new code ignoring the .venv, so you won't have conflicts and your code will kind of wrap around your virtual environment. Your virtual environment won't get destroyed each time you pull new code. There's more than one way to do it. This is a really straightforward way to do it. It has a couple caveats because your virtual environment's in your application folder, but I've done this for years and it works out just great. Now that we have that virtual environment created, we will activate it. And again, I'm just copying these off of the tutorial and we activate it. Once it's activated, you'll notice it has a little .venv preceding your terminal prompt. So that is fantastic. So we have the code downloaded and we have virtual environment. So now we need to add our requirements. There's only one requirement for this, but it's a very important part of Python apps is pulling your external requirements. There we go. We are done. So we are in a position now to actually test the application. So I'm going to go over here and I am going to clear. Oh gosh, that would be in the terminal. I'll just put the word break in there. That's what I've usually been using. So my brain is being fried a little bit here. No big deal. So that break is provided so that we can see when new stuff comes through. So it's like, kind of setting a stamp and stamping the time of when we do this. So we're going to give it a test. We're going to run the main. There we go. Look at that. Default response. This is exactly what we wanted. Every 15 seconds, it's going to give a new timestamp, default response, every 15 seconds, forever and ever. That's our application. And I'm going to stop that from running so we can do a little bit more work. The work we're going to do now is set up the instance to automatically run the Python application when the server reboots and starts. Because if we were to run it there and restart, it wouldn't automatically run. We want this to always be running. Power goes out at American Cloud, God forbid. We want to have the server come back online and just pick up where it left off, continue running, okay? So the way we do that, there's many ways to do that, but the way I'm choosing to do that is through cron tab. And the command we can use is cron tab -e. Pick your editor. This only happens once. This is because I don't have a cron tab file yet. And we'll get down here, we'll get to the end of the line, and I'm gonna add some commands. And again, copying these right off of the tutorial, I'll give you a quick explanation of what they're doing. And I'm even copying them with the comments here. So there's two commands that we're running. I'll start with the bottom one first. This bottom one says, when you reboot, using bash, run this startup script. Now, startup script is included in the repository. So if you need to change the startup script, you can do it locally, test it out, and then ship it. And just keep your file name the same, obviously. So that means every time it reboots, we're going to run that startup script first. But before we do that, step 0 is this one. This is modifying the read-write permissions to executable for that startup script. That startup script always needs to be executable. When it comes in from GitHub, it's not necessarily going to have the right permissions. So every time the server boots, just run this simple, tiny, little itsy-bitsy command and make that executable. So server starts up, make sure it's executable, runs that file runs the app, we're good, we'll see it in Slack. So let's save that. I believe this is unnecessary, but it's just sort of a good practice, a habit, maybe paranoia. I'm just going to run that same executable permission change on the startup file right now. So we're in good shape now. We have fresh code pulled, we know it's working. And we have also told the instance to automatically start this application using the startup file. So I'm going to put a break in here. And what we will do is reboot the server. Restart this instance. We should immediately get booted out. We will prime ourselves to come back in, copy the password out of readiness. And there it is. You can see right here, we have it starting again after the break that I just put in there. So we are running, everything is done, everything's complete. I'm just going to show you one more thing really quickly. Let's get our password in there. Cool, we are logged in. Now I want to show you one more thing that's included in here. We're going to change directory into our AC Python folder. And there is something in here called deploy. So I'm going to just read through the deploy script really quickly and run it once, and we will wrap this tutorial. So the deploy script used to be some massive deploy script I wrote over 10 years ago for some PHP applications on virtual servers. And in the old version of this, I was cloning and then wiping out the clone and recloning. And it's a perfectly good way to go. I would actually take the existing code, throw it into an undo folder. So via the command line, you had one undo, one reverse that you could do on the application. It's just as easy to do that in GitHub now. And for Python, I consider this to be a better approach. So I'll run through the basics here. First, we clear. The reason I clear is because I'm OCD. Even though this is running in the background on a server, I put it there. It's actually really nice because when you do run the deploy manually, it just clears your screen. It lets you kind of have a starting point to see any messages that come through. The next command that is pulled, well, before I talk about that, I have it wrapped in a conditional. That is just a remnant that I left in there so you could add arguments to your command line. So you could go deploy sh, command 1, command 2, and that may be something that you want to do. You may want to perform a different action than just deploy. So it is wrapped and ready to go there. Then what we're doing instead of cloning is I'm forcing the head to be reset hard. So it's a dash hard head reset, and what that does is sort of moves the head backwards in time in Git, and this is removing the potential for collisions. The collisions that you'll run into absolutely will be on the startup file because you change the permissions. That will come across as a differential, as a different file because of the permissions, and that will block you from being able to do a pull. So there's a lot of ways to kind of do this. I'm not going to guess at what those permissions are. I'm just going to nuke that repository, the local repository, back a little bit so that it's back in that original state, and then we will be able to do the command that we actually need, which is git pull. And that's all there is. So let's run that. DEP, we will deploy. So you'll see really quickly, it'll do the pull, and then, oh, I forgot to show you. At the bottom, there's one more command. We're rebooting the server after the deploy. If you don't want that to happen, that's fine. That's your call, but you should reboot the server after that. So let's run this command. So you'll see the pull really quickly on the top, and then it's going to boot us out because we're hitting a reboot. So boom, and we're out. Now that we're out and it's rebooting, I'll put a break message in here. I'll position ourselves to log back in because that's just what we do. We copy the password. And it looks like it is restarted. Whoops. And you can see already we have the default response going. That's it. That's your MVP. That is what you need to do to get a Python application running in American Cloud. You can take this same work and pattern, you can pass this to any language that you want. This is a real nice bare bones way to do it. I've never seen anybody do it quite as simply and efficiently and well thought out as I have. If you know of a repository like this, send it my way. I'd like to see how they did it. And of course, if you have any changes or suggestions to this, let me know. I'm interested in having this be a collaborative project over time. I want this to be a resource for people using American Cloud and other cloud servers to get minimum viable products running in the cloud. And be it a scraper, or you take this and you build upon it and you have a database and all these other things, or you end up going Docker, that's great. But here's your bare minimum: Bash, Python, Ubuntu. It works great. Again, my name is Mark. Find out more about me at mark-w.com. And I thank you for your time. Have a good day and have fun.